Hello. I got an email from Mike back in June inviting me to come and present here today. And I immediately said yes, because this is a topic super near and dear to my heart. PlayFab, my company, we provide a backend. We provide tools that game developers use to build, launch, and then operate their games. And this includes analytics. But unfortunately, many of the developers building games on our platform don't use analytics enough in their game. And nothing makes us sadder than seeing a developer spend a year or longer working on a game, launch the game to big fanfare and excitement, get promotion from Apple or Google, make it on the homepage, tweet about it, blog about it. We're so excited the game is launched, big surge of traffic, DAUs up the charts, it's all exciting. And then within a few weeks, the promotion ends, the traffic ends, the players go away, and the game begins a slow slide toward what we euphemistically call sunset mode. That makes us really sad. And in many cases, this happens because the game didn't have the data it needed to track its success and be able to change what they needed to change during testing and soft launch to make it a success. And so in 25 minutes today, I am not going to teach you everything you need to know about analytics. That would be impossible. What I hope to do, though, is point you in the right direction and give you just some tips about how to start thinking differently about analytics. And hopefully, that will make you more successful and your games more effective. So a couple quick questions. I want to understand who's here today. Raise your hand if you are an application game developer or publisher. OK. Raise your hands if you have analytics in your game today. Great. Raise your hand if you have made a change in your game historically based on having data from your analytics team. Actually making a change based on data. Only a few people. OK. Raise your hand if you knew you needed to make a change but didn't have the data you needed to make the change and felt like you were flying blind making those changes. Good deal. OK. Well, this is hopefully the context of what we're talking about today, how to use the data more effectively to actually make changes. So some quick context. I did not create the presentation entirely myself. Damon Daniele is a good friend and CEO of Appareee, an analytics company in Seattle. And they're one of our partners. Damon knows way more about analytics than I ever will. And unfortunately, he couldn't be here today. But he was a big help in pulling this presentation together. So common story. You spend a year building your game. You haven't thought about analytics until the very end. At the last minute before you launch, you cram something in. You soft launch in Australia or Canada. You immediately start getting some data, what we call vanity metrics, like installs or revenue or logins. You pat yourself on the back because you have data. And it's good to have data. It's good to know how your game is performing. The problem is this is not actionable data. We call these vanity metrics because they make you feel good, but you can't actually do anything about it. So for example, take this login graph here. What do we know about the game from this login graph? They've had 1.3 million logins in the last 24 hours. That's good. What else do we know about this game based on this data? Anything? Shout it out. OK, so what country is this game in probably? USA. This is obviously a North America game because there's a big trough at around 3 a.m. It's about all you know from this. You can't do anything. There's nothing you can actually do in the game based on data like this. Let's look at another graph. Let's look at retention graph. So I don't know if you can read these numbers. This is a typical retention graph. This is day-by-day retention versus, say, week-by-week. What you're looking at is down the left-hand side is what percentage of players are still playing the game after 1 day. And then second column, day 2, day 3, day 4, up to, say, in this case, roughly day 10. And then each cohort, each row, is showing you the batch of players who installed the game for the first time on that day. So for example, on May 30th, we had 763 players install the game. What can we tell from this data? Is this a game that is succeeding or failing? Anyway, raise your hand. Succeeding or failing? What do we think? This is greater Memorial Day. Yes, when people were home, they spent more time playing. But what else? So to me, this is a game that's failing. It's failing because day one retention of around 30% isn't great. It means only 30% of your players stuck around on the second day after they installed it. And by the time we get to day 7, we're down to 10%. That game is not going to do too well. You typically want to see a day 1 of 40 to 60 is good, 65%, or I've seen games of 70% or higher day 1 retention. That's really what you want to be. So this is useful. It's showing you that you need to make some changes. It's telling you you've got some problems. Your players are falling off too fast. But now what? So what? What are you going to change? Again, this is not actionable data. You can't make a change based on this kind of data. So what I'm going to propose now is a different mindset. If you remember only one thing from this talk, remember this diagram. The basic idea is when you're building a game, your game will be flawed. Your game will have problems. No game in the history of gaming has ever gone into soft launch or launched for the first time and been perfect. You have to be prepared for that, and that means you have to be prepared to make changes to your game to improve it. So what you need is a learning mindset. You have to have this attitude of improving and iterating and learning about your game. And so this basic cycle is the same basic cycle they teach as part of the Lean Startup Framework. It's the same exact cycle I was taught at the Walt Disney Institute, where they teach about how they improve their theme parks. And it's what every good game designer I know follows. The basic idea says, you have your game, measure the game, gather data, figure out something about the game that is important, come up with an idea for how to improve that part of the game, try something, run an experiment, do something to try and change that part of the game, measure the result, and then repeat. It's a simple framework, right? Gather data, come up with an idea, try something out, and then measure the results and repeat. It's a simple, simple idea. Most developers, many developers, don't even do this basic thing. They fly blind. They say, well, the game's not doing well enough. I'm going to just go in and start monkeying around. And maybe they look at the vanity metrics, but they're not using data, the actionable analytics. They don't use enough data to actually figure out what to change. And that's what we're going to talk about today. So if you're going to remember anything from today, remember this basic cycle. So let's look instead at some data that is actionable. So one of the most basic places to start is just looking at your level completion data. Here's the mindset you want. What your mindset you want is, let's take retention. Let's say you're trying to improve retention. What you want to do is you want to ask yourself, the players who stuck around, the players who love my game, the players who are still playing on day 7 or day 10 or day 30, how are those players different than the players who didn't stick around, right? So go way out in the future, like day 30, and say, of the players who are still playing on day 30, how are they different from the players who stopped playing on, say, day 1? And once you compare those players, then go back in time. Go back to a point where you still had both players in your game and say, how are these players different? How is a player behavior on, say, level 1 different for a player who will eventually churn out and stop playing compared to a player who will eventually keep playing and make me lots of money? And so kind of going back in time and looking at the data to compare your players, that's the essence of starting to use data to make it actionable. So in this case, we're looking at here level by level data and saying, let's look at the population of players who stuck around, the gray data on top, versus the players who churned out. And by churning out, it's a fancy way of saying they stopped playing your game. So let's look at this graph. What are some immediate things that jump out at us as the places we might want to zoom in and try to fix? Day 1. Day 1's got a problem. Something's happening on day 1. Right? A huge chunk of players are leaving on day 1. What else? Where else might I want to look? Day 6. Now, day 6 is a little funny because it's actually day 6 plus to level 10, so there's actually a bunch crammed in there. But still, I would absolutely look there. Something's happening around level 6. You got another kind of bunch of players trying to churn out. And so what you might want to do here is go back in time to level 1 and start to ask yourself, what's happening in level 1? Why are players churning out? And so what you want to do then is dive in and come up with a hypothesis. How are my players who leave on level 1 different from the players who stick around? One hypothesis could be, in this case, it's simply too hard. That's the most obvious thing. It's too hard. But maybe it's not that. Maybe what you find is the players who stick around are the ones who earned an achievement right away, very quickly. The players who didn't get that positive reinforcement, they're the ones who dropped out. That might be one theory. Let me tell you an example from my old company. Before PlayFab, I was at PopCap Games for 8 years. And Plants vs. Zombies, probably one of the more famous games PopCap published during that time. And we were doing play testing. This is before the era of soft launching. We were doing play testing with players in our office, and we had a problem. We were analyzing all the data, and we detected this huge drop-off in players leaving after the first level. It turned out newbie players, brand new players, casual players who were not used to games, kept quitting after level 1. They said, the game is too hard, it's impossible. But experienced players, players like the kind of people who work at PopCap, thought the game was fantastic, and they were not having any problems. If anything, they thought level 1 was too easy. And so we had this conundrum. What's going on? Why are players dropping out? Why are beginner players dropping out after level 1? And experienced players are saying this game is easy and fun and super awesome. So we went and looked at the data. And what we found was this. A newbie player, this is a typical level from a newbie player. They were basically planting all pea shooters, no sunflowers, and they never got the economy going. They just were not generating any energy. And so as a result, they kept dying. And they were really unhappy, and the game felt too hard and really frustrating. And so we had what seemed like an education problem. Our hypothesis was, we need to teach those players to plant sunflowers. And we had all these ideas about how are we going to teach players better. Anytime you start blaming teaching or you need to educate the players, you probably have bad game design. This was a game design problem, not an education problem. And so we had a lot of brainstorming. How are we going to solve this problem? And the solution we come up with is, I think, brilliant and totally not intuitive. Any expert PvZ players here recognize what's different about this game than the final version we shipped with? It's a really small, really subtle difference. In the back. No, the question is, do we have a row of sunflowers? It didn't start with a row, no. You had to plant your own row, yep. Right, okay, he got it. So if you look at this top level here, it's hard to see because it's darkened, so let me go back. This is how the level was starting. The level was starting with 200 sun power, and the sunflower was 100, and the pea shooter was 100. And what happened was, given a choice, people were planting pea shooters because they figured it's better to have a weapon than what's the sun thing. And that was basically their undoing. So we made one teensy little change based on the data. We changed the price. We changed the sunflower to 50 and the pea shooter to 100. And we started out by giving you less sun power. I think we started with 0 or 25 sun power. And so what happened is you would earn 50 sun power, and the only thing you could afford was a sunflower. And so you plant a sunflower. And then it would reset again, and you start earning more, and you get another 50, and you plant another sunflower. And so without any teaching or training or tutorials, the natural progression became plant lots of sunflowers until you had enough energy that you could finally start affording pea shooters. And so just that one little change made a huge difference in the data. And suddenly we saw retention numbers go from like terrible to awesome for beginner players. And so I love this example because it shows how the data helped us figure out a core design problem that was invisible to us. We didn't see it because we were all experienced players. Anyone who's ever played an RTS would not have made that mistake, but newbie players were making it left and right. So I love that example. So once you've got your idea, your theory, you have to try it. And this is the next challenge, is how are you going to try your ideas in the game? What you want to try to avoid as much as possible is changing the code of the game, if you can avoid it. Because unfortunately, in today's day and age, if you've got an iOS game, let's say, and you want to make a change, you're waiting 2 weeks minimum before that game gets updated and refreshed and put back out in the market. And that's a lifetime if you're in soft launch mode. Android's more forgiving, and I know a lot of game developers now who use Android as their primary iteration vehicle because it's a faster turnaround time. But you still want to avoid having to make code changes to test out new ideas. So so the question is, what tools do you have to change the game? One very common tool is totally not intuitive, and it's targeted messaging. The idea that if you've built into your game some mechanism for sending push notifications or other messages to players, you maybe can't change the game itself, but you can at least communicate with the player. And so what you're seeing here is a typical automated campaign cycle where they've set up a whole bunch of rules, such as players getting stuck on level 8. And if your game is designed properly, you can, in your messages to players, include GIFs or other items. So you can do things like, hey, if players are getting stuck on level 8, send them an extra power-up or a boost or some item, or simply a tip or a trick, or just plead with them to keep playing the game. But the idea is giving your team the ability to message your player at different stages during that game starts to give you a way to test out new ideas. And then once you find something that works through this kind of method, you can go back and change the game. Now, this is not a great tool, but at least a tool. My company happens to make a set of tools that we like. This is an example of what we call, you probably can't see it in the back. We're basically able to create segments of players and change certain variables in the game based on those segments of players. So in this case, we're actually changing some data in the game if the level 10 tries is greater than 5. So basically, if a player is getting stuck on a level, change the level difficulty while they're still playing. And so this is actually really cool because you're actually starting to get into the idea of real-time changes, actually changing game behavior in real time while the player is playing the game. And if you have a tool, or if you build for yourself tools that allow this kind of customization, you can really start to go in like a surgeon with a scalpel and shift and change and experiment. A lot of game designers I know will have often a dozen or more different experiments going at any given time while they're in soft launch, because that soft launch period is precious. You only have, depending on your budget, sometimes a few weeks or a few months to tune the game. And if you can't get your retention numbers up, your monetization numbers up enough during that time, you may never launch a game at all. And so the more experimentation and tuning you can do based on this kind of data while you're in that soft launch period, the better. Another common thing, again, I'm just using my own tool because we had the screenshots, but there's a lot of tools out there like Swerve and others that make it easy to do A/B testing. A/B testing is another really valuable way to experiment with games. The difference in A/B test is you create some variable you're trying, like you think you have, the data tells you level 5 is too hard, so you're going to try different difficulty levels for level 5. So you go in, you create a whole bunch of buckets, and you assign to each bucket of players, let's say 5 buckets at 20% each. Each bucket of players gets a different difficulty level or difficulty ranking for, say, level 5. You then run it for a few days or a few weeks, and then you look at the data and you see what happened. Did it make a difference? By making level 5 easier, did you change the metric you were measuring, in this case, let's say day 30 retention? And if it made a difference, great, keep the change. If it didn't make a difference, go back to what you had. And again, many companies will have many A/B tests running at the same time. And this is where your data scientists really come in handy, because a good data scientist can do true multivariate testing and be running lots of tests at the same time and tease out of the data which were the key changes that really mattered and which ones weren't. Because otherwise, it can be very difficult to figure out what's going on. So once you've run your experiments, once you've tried all your different tests, then you go back and you look at the graph again and say, did it change? Did I move the needle the way I thought I would? And it's really important to have kind of scientific rigor here. You have to have your hypothesis. What do you think is going to happen? Run the test. Look at the data. Did it move? And did it move the direction you expected? And if it does, great. If it doesn't, you have to ask yourself why. What happened? Why did it actually get worse, not better? And then again, go back in the data to try to figure out what was the change that you expected or didn't expect. So that's the basic, right there in a nutshell, that's the basic cycle the games have to do. And so the mindset needs to be, design your game from the beginning to be testable, to be able to learn, to have that sort of very rapid learning cycle. Because if your game is not designed with the right tools and the right metrics and the right data to allow you to measure what's going on and test it, you're going to squander your soft launch period, and you're going to go live without, frankly, the game in as good a shape as it can be in. So what do you need? What are the tools you need to do this successfully? You need 3 things. First of all, you need really, really rich data. And there are a lot of analytics companies out there that are wonderful, that specialize in really pretty graphs. And pretty graphs are great, and executives love them, and you can put them on big monitors in your office and walk in every day and see the big graphs and feel good about yourself, but don't fool yourself. Those are vanity metrics. They might make you feel good or bad, but they're not going to help you make the game better. And every successful team I know has somewhere, either on staff or a relationship with, a data scientist, and they have a data warehouse of some sort storing a lot of data about the game, enough data that they can actually go in and really start to figure out what's going on. We're at Amazon Dev Days. I happen to be a big fan of Amazon Redshift. It's what we use at PlayFab. Amazon Redshift is a classic data warehouse product that allows you to take a lot of data across a lot of players and do very fast analysis across an enormous amount of data. You don't want to be trying to do this in SQL or Excel or some ordinary relational database. It's just not, those are not set up for the kind of data that you'll be gathering. Totally Amazon Redshift is, but you do have to make sure you're gathering the data in the first place. And I know one friend of mine, Chris Coe, at This Game Company up in Vancouver. It's called This Game Company. Ex-Kabam, he ran live ops at Kabam. He was showing me the data schema, the data that they were gathering for that game. He'd spent months thinking about what data to store, so when they finally did go soft launch, they would have the data they needed to actually be successful. And unfortunately, I couldn't show you his schemas, but he was storing every time a player leveled up, killed a monster, bought an item. Not just was he storing that he bought the item, but a lot of stats about the player at the time the item was bought. So for every one of these events, like buy item, kill monster, level up, he was storing a lot of other dimensional data. Data like the player's level, the player's health, how much money they had in their bank account, because those other factors sometimes are the key insights. For example, it might turn out that knowing how much health the player has left at the time they're spending money is an important factor. And maybe you decide later on you're going to go back and maybe make the game harder because it increased monetization, for example. So you need rich data. Number two, I already mentioned you need the events. You need the raw data themselves. And three, you need those tools to be able to change the game on the fly post-launch. And if you're using a platform that does it for you, great. If you're building your own backend, great. Just make sure you build in the tools to allow you to configure the game on the fly. A common technique these days is to configure your game with JSON data and make sure those JSON data files are all stored on a server somewhere. Don't bake it into your client. That's bad. Have all your configuration files on a server somewhere so you can change them. So every time the game runs, it downloads the latest configuration so you can change it post-launch. And so again, your entire architecture should be designed around this idea of making it easy to change and learn as you go with your game. So that's it. Pretty simple thing. Think about learning, that iteration loop, gather the data you need to do that, and make sure you can run experiments. And so with that, we've got our Twitter address up there, our website address. My email is james@playfab.com. I've got a minute and a half left, and I've got some balsa wood airplanes to give out as gifts for anyone with some questions. So question right there. Oh, the question is why not resubmit to Apple? I'm not saying don't resubmit to Apple, but the approval process can be, in some cases, as long as 2 weeks. Is it 2 days now? If that's true, that's wonderful. If Apple's got it down to 2 days, that makes it a lot better, because that was one of the biggest barriers I heard before was the long cycle time on changes. Right, the question is, should you make it easier for people who are struggling and keep it hard for expert players? And you'll have to test for your own game. We found the PopCap, it was possible to be too easy. And so if it's too easy, advanced players will quit. Too hard, new players will quit. And so being able to adjust the difficulty really helps. For example, Crash Bandicoot. I don't know if you remember Crash Bandicoot, the classic platformer game. They do some really clever things in there. If you die 2 or 3 times in a row, they give you come to life with like a defense, what do you call it, like a shield on you to make it easier to survive. So that's an example of dynamic difficulty tuning, where they're making it easier as you play if you're too new. Because yeah, you want to be hard if you're to appeal to the advanced players.
A lot, you mentioned having a data scientist on staff a couple of times. In a lot of my startups, we didn't even get a data scientist until we were like several years old. So what would your best advice be if you're running a pretty lean 1 or 2 person shop?
Yeah, that's a good question. So if you don't have access to a full-time data scientist and you're doing it yourself, learn basic SQL. It's not that hard. Your engineers can learn the basics of analyzing the data. And keep your questions simple, right? So something as simple as, the chart I showed you. Every level in your game, how many players are quitting at each level. That's a really basic sort of funnel to analyze. Or your tutorial funnel. Ask yourself, what are the first 20 things that you want a player to do, and then measure your fall-off rate for that funnel. Those are some relatively basic things you can do that will get you started in the right direction. And then find a friend. One thing we did at PlayFab actually is we recruited a data scientist from the University of Washington part-time to help come in after hours and help us on an hourly basis. And so you can be crafty in trying to find folks who know the data. I will say this though, a lot of university students who are taking degrees in statistics or data analytics, they're always looking for term projects or class projects, and they actually have a lack of real-world data. So if you can say, hey, I've got a game, and I'm generating gigabytes of data, I'm willing to give you the data in return for you doing some analysis for me, that can be another way of getting some scrappy data science help.
Fantastic. James, thank you very much.